Hello everyone, I'm Priya, Technical Marketing Engineer from the Campus Switching side. In today's session, I'll talk about AOS-CX containers and the new enhancement in the 10.14 release. Let's dive into the content. So here's the usual agenda for our session. So let's jump into the overview. Why do we need containers on a switch? Containers on AOS-CX switch offer significant cost savings by utilizing existing infrastructure and eliminating the need for additional equipment. This setup reduces unnecessary maintenance or updates, making it highly flexible and easy to troubleshoot. Enhanced security is achieved as applications on the switch are harder to access and cannot be easily removed, unlike traditional servers. So placing applications closer to the edge reduces latency and bandwidth usage, providing faster response times. Consolidating data on the switch minimizes noisy connections to the server, optimizing the overall network performance. So that is an overview of why do we actually need containers on a switch. So let's talk about containers in AOS-CX specifically. For that, we'll have to understand the components of the CX container. So container manager. The main process that manages this container lifecycle in CX is the container manager. It is responsible for loading, starting, and passing configuration into the running container. So the next component is runc. So runc is a container runtime software component responsible for running containers. These runtimes interact with underlying operating system kernel to allocate resources such as CPU, memory, and storage to containers, ensuring isolation and efficient resource utilization. So the next main component is the container network interface. So the next main component is the container network interface. This defines a set of specifications and libraries for network connectivity and ensures that containers can communicate with each other and with other resources, providing consistent and reliable networking. And the container network is the network dedicated to containers, bringing the connectivity both internally and externally. And finally is the OSDB, that is the AOS-CX system database. So let's talk about runc and its functions. So runc is the container runtime used by container manager, and the container manager is a lightweighted version of the container daemon. It is also an underlying component for Docker, which is used to create and run containers. So if you see here, there is a comparison of AOS-CX and the Docker environment. So here it's the container daemon that is responsible for pulling images and managing the networks and storage, whereas in CX it's the container manager. And runc is the common component that is running for both. And hence we declare it as the same container runtime, which is responsible for creating and running the containerized processes. So one important thing to note here is that why container daemon has not been updated or implemented in the CX environment. So AOS-CX doesn't have the ability to pull the container images directly from Docker Hub or from any other private registry. So for this, we use the Docker save to export an image to a tar file. This Docker save is a command. And runc is capable to extract the requested files from this tar archive and run the respective container. So I hope the architecture is now much more clear. So we have two enhancements as a part of AOS-CX 10.14 release that we will be deep diving in this session. So the first is support for unsigned container images in AOS-CX. The next one is preferred VRF and port mapping. So we must understand why this enhancement is essential. So for that, we'll look at an overview of the container environment before 10.14 and also with 10.14. So for users to host applications of their choice, they can now make use of CX containers, thus increasing the flexibility to host custom applications without imposing the restrictions for image signing. So in other words, users are provided with configuration options to explicitly allow non-HP signed applications or container images. So before 10.14, we had support only for vSphere agent application. So from 10.14, you can see that the container image of your choice can be built inside CX, and these are unsigned, and you don't have the necessary for them to be signed by HP. So apart from this, additional event logs are also enabled for the container status validation, which we'll be looking at in the upcoming slides. And these applications that you host inside the CX containers can be a web server, it can be an NMS relay, or it can be an FTP server. So any application of your choice can be customized in the CX environment. So let's look at an overview about VRF and port mapping. VRF, as we all know, enables segmentation and isolation of network traffic within containers, enhancing the network security and management. Containers or container groups can be associated with a specific VRF, allowing for customized routing and separation of traffic. This means that each container can operate within its own virtual network environment or across multiple VRFs, ensuring the clear separation of data. So we spoke about what is VRF and containers. So now let's talk about the network namespace. So network namespace is a Linux kernel that provides isolated network stacks for processes within containers. Each container possesses its own network namespace, as illustrated here, ensuring network configurations remain separate from those of outside containers. So before 10.14, the container infrastructure allowed the user to attach a container to multiple VRFs. However, the container application ran on an isolated environment, and it was required for this particular application to be VRF or namespace aware, so that it could switch from the isolated network namespace into the others that were made available to the containers. So if this container application has to reach outside, it should know the available VRFs is what we're trying to say in this. So now from 10.14, the container applications need not be VRF aware anymore. So let's look at what is new in the preferred VRF and port mapping. So let's look at what is new from the 10.14 release in the preferred VRF and port mapping context. So from 10.14 release, we allow the customers to set one of the attached VRF as preferred. This means that application can have connectivity by default on the specified preferred VRF. thus allowing for proper functionality of the VRF or namespace aware applications. While the user can still attach multiple VRFs to a container, most standard applications will only use the one set as preferred. Apart from this, we also additionally allow to map a switch host port to the container port so that requests received by the switch on that port will be redirected to the container. External port mapping on CX enables external resources to access container-hosted applications efficiently. However, we have to note that only one VRF can be assigned as a preferred, though there are multiple VRFs. So here, for example, I have VRF management, I have VRF default. I have highlighted this to show that I have assigned VRF management as my preferred VRF. And when you expose a container port by mapping it to a port hosted on CX, it can be either a TCP port or a UDP port. So the current existing infrastructure on AOS-CX containers is using source NAT. So from 10.14, we have both source NAT and destination NAT. Now the container application and the external host can reach both inbound and outbound to and from containers. So here are the platform support for these two features. It is not supported on 4100i, 6000, 6100 and 6200. You can see the other supported platforms listed here. This feature is also not supported on the AOS-CX simulator. We also don't have support for 6300L platform yet. And the reason for containers not being supported on 6200 is the hardware resource restriction. And also that it doesn't have any feature pack capability. So let's look at the use cases of this feature. Containers can bring additional services and extend capabilities by running network services, app relays, and brokers. They can act as extenders or relays for platforms like Aruba Central, simplifying the automation process. A few examples that I would like to highlight for extender or relays is network monitoring, or let's say load balancing. So these can be containerized applications or services that in turn serve as an intermediary to optimize performance and relay data to Aruba Central. Simplified automation. A container running automation scripts to push configuration updates to network devices managed by Central. Another example is an event handling container service that automatically responds to network events, or by executing predefined actions such as notifying administrators or attempting a restart. These are few examples of how containers can be used. So let's look at the details and caveats. With dedicated and hard restricted resources on devices for running containers, we have two types of resources. That is, two types of resource limits: global and user configurable resource limits. So global limits are shared among all the containers, while user configurable limits can be set individually for each container. Let's say if a container requires more resources than default, users can manually configure these limits during the container creation process. This flexibility ensures that the containers have necessary resources to operate efficiently without impacting the other containers on the system or the system performance. So talking about the default values. CPU and RAM are hard restricted to 20% of the device resources, and the CPU and RAM attributed to a container are by default 10% of the CPU and 256 megabytes of memory. Another thing is about image size. So CX containers can maximum support up to an image size of 500 megabytes. If the image size is exceeded, then the containers are not operational and they remain down with the error called unpack fail error. So the use of containers on the AOS-CX devices definitely requires a CX advanced feature pack. Container images are platform dependent. These can be ARM-based platforms or 86-based platforms as listed. So let's move into the other details. So before we dive deep into the container config, we have to understand a few details about this switch operation modes. So there are two modes of secure switch operation modes. The first one is standard mode and the next one is enhanced mode. And we all know that the default mode is standard. So whenever a switch shifts from the standard mode to enhanced mode, a zeroization is required. So here is just an example CLI of how the switch goes from enhanced mode to enhanced mode itself, and again from standard mode to enhanced mode. So you can refer these two CLIs for further details. So running the switch in the standard secure mode and again using the allow unsigned parameter. So how does that work? So here let's say I'm using a signed image by HP and I'm using the allow unsigned parameter which is set to true. So in that case the container is deployed and the allow unsigned parameter is set to false. The container is still deployed because it's a signed image. Now let's consider an unsigned image scenario. Using the allow unsigned parameter, the container is deployed, but without using it, it is not, which is straightforward. So these are all in case of standard secure mode. And once you deploy the allow unsigned parameter and a new container image on it, you will see a potential security risk warning, which states that HP shall not be responsible for the consequences. So now running the switch in the enhanced security mode and then using the allow unsigned parameter. So when the image type is signed, the container is deployed, and same is the case for the signed image. When the allow unsigned is not used, the container is still deployed. And finally, unsigned images are not permitted in the current secure mode, which is enhanced secure mode. So deploying container images in this mode will not have any effect, even though you use the allow unsigned parameter. So few other details and caveats. If an ARM image is downloaded on an 86-based platform and vice versa, the container will remain down without any specific message. And a few things to note here are, if the configured image has been downloaded and verified by Container Manager, in case of a restart, let's say, the image will not have to download again unless the image location, including the container name, is modified. So you can use the same old image. This also applies when using the allow unsigned parameter. If a redownload is required, just modify the image location URL or remove the command and add it again. I'd also like to highlight that we don't have any CLIs yet to stop or start containers inside CX. Few more details and caveats on the functional requirements and the optional configurations inside CX containers. So image downloaded from the given URL and VRF is a very fundamental requirement, and images can be downloaded only from a HTTP server. We don't have support for HTTPS, TFTP, SFTP and SCP as of now. Image location VRF is used by the switch to download the container image. And we'll also have to make sure that the image location VRF and preferred VRFs are completely two different things. Few optional configurations inside the container are environmental variables, which are application specific. These are nothing but key value pairs that contain data that can be used by processors running inside the container. They are often used to configure a particular application setting. And few other optional configurations are CPU and memory restrictions and no storage. Attaching the container to VRF for an external connectivity is again an optional configuration. Can be done if needed. So, a maximum of 2 containers only can be configured in AOS-CX and not more than that. Few more things to highlight in the details section is VRF selected as preferred must be definitely present in the switch. If the preferred VRF is not specified, then the default VRF is used. So once you use this VRF configuration, port mapping entirely depends on the preferred VRF. Any change related will restart the container. So there can be multiple port mapping configs, and we have to make sure that you don't allow any host port conflicts. So when a container is attached to a VRF, what happens in the background? A virtual bridge with IP address, as mentioned, is configured to connect the container with the VRF. So this allows containers to communicate with the host, that is AOS-CX, using the virtual bridge. So the main limitation here is that we allow only 10 host ports per VRF per protocol. So let's move on to the configuration now. So here is an example of Docker Hub. So here is an example of Docker Hub, which has n number of applications with different categories like MySQL, web servers, and few other images. So you can pull the image of your choice from here. So pulling container images from Docker Hub. The below example shows an image and its respective Docker command and the tar file that will be downloaded by the switch. This download must be done on an intermediate node like a server or a laptop, as CX doesn't have the capability to download an image directly from Docker. The switch can be pointed to a HTTP server to obtain and run the container image. So as I showed you in the Docker Hub website, you can see the Docker pull command for the particular application of your interest. I have used an application called Deep Hub, which is a basic warehouse tracking application. So I'm also trying to save it with the Docker save -o and the respective image name command. And you can see that my Deep Hub container images are saved here. So I use this image for building the application of my choice in the CX container. So Container Manager uses runc as the launching infrastructure. Hence, the recommended way to manipulate container images is to use Docker. So if you're using an 86 system as a development machine, then I would recommend you to follow the below steps. And if you're using an ARM architecture, you need to make sure you have a Docker version of 1903 or later, and below are the commands to build your container image. And finally, you will save the image using these commands. Here is a sample HTTP server configuration for your reference. So, unsigned image download configuration. So, the new CLI command from 10.14 release is the allow unsigned parameter under the image location context of containers. So, the container and its name, and once I issue the container name, I get into the image location context. I specify the URL from where the image has to be downloaded, and I also tell it the VRF name along with the allow unset parameter. So that is how you break down this CLI. Here's the help context for your reference and the risk warning that we already discussed in the previous slides. And once I tell all these necessary details, my container is operational now. So in the case of port mapping and preferred VRF. So the preferred VRF and port mapping have two new CLIs. The first one is preferred, which is very straightforward under that particular VRF context. So here, network VRF and whichever VRF of your interest, you get into that VRF and you tell that VRF as preferred. And in port mapping, you have the port map of host port, its respective port number. This host port is the CX port, and then the container port, its respective port number, and the protocol, either TCP or UDP. So here is an example of how you configure this. This is an example of REST configuration for unsigned images under the system's container context. The allow unsigned image parameter is true with the image download VRF and the image location. My container name is deephub in this case, so hence deephub.tar, and few other optional configurations. So this is successfully executed, and this is how the REST API output looks. Here is yet another example of setting the preferred VRF and port mapping through REST API. This is again in my deephub container under the system container network context, because this is the network configurations that we enable for both inbound and outbound communication. So I have my port mapping config for that particular container along with the preferred VRF config here. So that's the respective output. So now let's move on to best practices. So when I say best practices, it is always recommended to configure all the additional items like network VRF, the resource details, or the CPU, and then even the environmental variables before to start the images download. So this will ensure that all the required configurations are taken care of when the container starts. So this will avoid any further delay for the container start. So let's look at the demo now. So I would like to give a gist of what has been done in the demo. So I have two containers, container deephub and container deephub UI. So my idea here is to run this application's UI and backend. So this is my backend container config and this is my UI container config. And these are the optional environmental variables, which is application specific. So here I have my HTTP IP along with the image name, the VRF and the new parameter, then the network configurations along with the port mapping configs. So same is the case for the UI as well. So my final goal is to run this warehouse application that tracks the finished products using the CX container. So this is just a sample show command output for both the containers here. You will also be seeing this in the demo. So here's the demo. I'm getting into the Docker and downloading the deephub and the deephub UI image respectively using the Docker pull. So here I have a 10K switch and the respective VM which I'm using. So here's the IP address of the VM. I'm just trying to see if the HTTP server is up and running, and you can see that it is serving at port 8K. So that's my switch IP. I'm trying to ping the VM and I can see that it is reachable. So I'm making sure the feature pack is up and running and is all in place for the container to work. So as shown earlier, I'm creating the container deephub and I'm also making sure the image location and the HTTP server along with the new parameter allow unsigned are mentioned. So that's the help context, and you can see the new one that is added from 10.14, and you add it. So after the warning, you just issue an S and your new image gets pulled. You can see that it's a 200 status as the image is pulled from the server. So next, let's assign the network configurations and the port mapping configs. So the respective port mapping for the switch and the container is here. So now I go ahead and create another container called container depub UI. So till now we did the backend part of the container. We're doing the UI part right now. So you can choose application of your choice when you're trying to run it. This is just an example of a third-party application running in CX. So that is a 200 status as well. Again, the network configs and the port mapping configs. So once that is done, I do a show command of both the containers depub and depub UI. And as shown already in the slides, you can see the similar output here. So those are the environmental variables for both the containers. And that's my switch IP, and I'm trying to do a reverse SSH to access my containers and give it some access to the external host. So now I see that my backend page is up and running, and my UI page is also up and running with the depub UI. So right now I'm getting into my VM and trying to execute a few set of JavaScripts, and these JavaScripts are application specific again, and I did this with the help of Node.js. So I'm just installing few prerequisite packages for that. I already have the depub modules here. So we will be running 2 or 3 modules to see how the application is operational. So initially I'm doing a add zone.javascript. So this is a JavaScript which will add a set of particular zones here. So once I get into the zones, you'll see that the particular zone is added. So now this is a UI running on the CX container, which is operational and running. Similarly, let me execute few more packages as well. Let's say I'm add fences, and here you see the respective output in the UI. So this is just an example of how that gets updated. And I also again go ahead and add providers. So you see a lot of providers added up here. So these are all the modules, and this is the page that I followed to run this particular demo. And once I start all these packages all together, we can see that they're all online, and it'll reflect the same in the UI as well. So that's just an example of how a container application is operational inside the CX environment. Hope you had a clarity on how it works. So let's move on to troubleshooting now. CX container status is split into various stages. A few are listed here. The first one is down. If, let's say, there is a prerequisite missing to proceed with the container initialization, then the container status is down. And initializing is the container initialization and config verification in progress. Operational, as you all know, it's just up and running. Network fail is the network provisioning that failed somewhere in the network config or the port mapping config. Execution fail is the container failed to execute. And configuration fail is the user configuration fail. There might be some typos in your config. And disabled is the container is completely disabled. And exited status is thrown when the container completes its execution and it exists. Similarly, we also have image verification status. So the newly added image verification status here is the allowed without signature. So these were already prevalent and this is the newly added status. So a few event logs and helpful debugging commands are debug containers all, where you can see that step-by-step process of the container being created. So here the container debug is created, which is the first step, followed by the image file signature verification. This is not an error and it also tells it is unsigned and allowed by the user. It is just the series of events. So image file signature verification is not an error, which is the thing to note here. So moving on to logging, a few new additional logs have been added as highlighted in the previous slides. So they are listed here. You can take a look at the set of logs, their respective messages and description. The respective messages and description. So show capacities containers. You can see that the maximum number of containerized applications configurable in that particular system is 2. So that's the container capacity in CX. And with that, we come to the end of this session. Thank you for listening.